Welcome everyone to this quick tutorial on calorimetry and how to set up the apparatus. So, as a quick run through, in your instruction sheet you've been given a list of materials which include a thermometer, a retort stand, 3 burette clamps to hold the thermometer, the calorimeter and food sample in place, a measuring cylinder capable of measuring 50 millilitres of water, food samples times 3, whatever you've chosen to measure, some aluminium foil, matches and the mounted needle as shown. We also need an electronic balance which will be used to measure the mass of the food samples. I'm just going to zoom out now on that one and we're going to get started with the experiment. So, I'm going to run through the method as I go so you can see how what I'm showing you relates to what's written. You have an instruction to place 1 pistachio onto the mounted needle. We're not using pistachios today, I'm going to be having a look at marshmallows. So hopefully you can see that we have here a mounted needle with a marshmallow on top. I'm just going to bring that around to zoom in a bit closer. So a mounted needle consisting of a cork on the inside wrapped in alfoil with a needle. What I need to do now is find and record the initial mass of this food sample and the mounted needle. I'm just going to place that on my electronic balance which has been pre-tared to 0 and record that initial mass as 8.28 grams. Very important that we record the initial mass before the experiment even starts. I'm now going to set this in place, so pop the mounted needle back into the burette clamp. And I need to check that there's no water in my calorimeter already. Okay, which there is, so I'm just going to dispose of that. Set up my calorimeter to be placed approximately 2 centimetres above that marshmallow sample and add in my pre-measured 50 millilitres of water. I just need to position the thermometer down into the calorimeter, so it should be touching the water but not touching the metal can. We want to measure the water temperature and not the temperature of the metal. Okay, so I'm going to have a look at the initial temperature, which is 19 degrees. I've already got that recorded. It's the initial temperature of the water before lighting the food sample. So I've recorded my initial mass, my initial temperature. Now I can go ahead with the experiment. So that simply consists of making sure there's a heat-proof tile underneath the apparatus, lighting a match to the food sample, okay. So what you can see there is that that food sample is burnt, it's completely black and charred, and no more burning is going to take place. I'm just going to zoom out so you can see the rest. Okay, so once it is cool to touch, obviously being mindful of safety, we need to make sure the water is stirring around nicely throughout the experiment. The water's been able to contact fully with the thermometer, otherwise it would obviously be a fluid test. And then we record the final temperature of the thermometer. So I can see that this has gone all the way up to 28 degrees during the course of that experiment. And now I want to determine the final mass of the food on the mounted needle. So I'm just going to use my electronic balance again, make sure it's on 0, place it back onto the balance. And that mass has gone down to 7.9. So we had an initial mass of food, 8.28 grams, a final mass of food of 7.93 grams. Obviously, the total mass has reduced inside due to some of that food being burnt away, which is mimicking the processes of digestion. So we can see that that is 0.35 grams worth of food that has been burnt away. Simultaneously, the temperature rose from 19 degrees to 28 degrees, so that's a total of 9 degrees Celsius change in temperature. We're going to use those values, that change in temperature value and the change in mass value, our calculation to work out just how many kilojoules of energy was in the marshmallow.